Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel. Today's topic of discussion is the TECO SG2 PLR client programming software. Our objective is to familiarize ourselves with the TECO SG2 PLR client programming software. We'll learn to navigate the software environment, enter a basic ladder logic program, simulate the program, and transfer it to a device and monitor its operation. Note this lecture is not intended to be a thorough review nor an endorsement of the TECO SG2 PLR family, but rather serves to familiarize the viewer with just one of the many inexpensive basic programmable logic controllers and programming software options commercially available. Recalling the example PLC, TECO SG2 PLR lecture, available at the Big Bad Tech channel, we familiarized ourselves with a representative example of an inexpensive basic programmable logic controller, the TECO SG2 10HRA PLR. During the course of that lecture, we programmed the device using the ridiculously small dedicated buttons and LCD screen on the front panel and learned the hard way that this is a time-consuming and frustrating task. Today, we'll learn to use the TECO SG2 PLR client programming software that makes the manual entry method feel hopelessly ponderous in comparison. TECO offers a fully functional version of this software for free on their website. While free, the software isn't particularly feature-rich. However, it gets the job done. If you've already got a copy of the TECO SG2 client programming software available or capable of downloading it, by all means do so, fire it up, and follow along. The TECO SG2 client programming software is proprietary software used to program devices in the TECO SG2 PLR family only. Other manufacturer devices necessitate the use of different software. While proprietary in nature and limited to only a handful of devices, most of the features as presented in this lecture are universal in nature, and only subtle differences exist between different manufacturers' programming environments. Ultimately, well-designed programming software will allow a user to do four things: write, save, edit, and manage programs, simulate programs, transfer programs to a device, and monitor a device running a program. Not only does it use the programming software like the TECO SG2 client programming software greatly simplify the program entry and editing process, the ability to work on a program offline without stopping the PLC reduces production downtime. Additionally, simulation makes it possible to test and verify functionality before going live with real-world hardware in a production environment. The version of the TECO SG2 client programming software I'm using today is version 3.37. Older or updated versions might feature subtle differences. The software initiates operation with a small window featuring rather stupid-looking cartoon characters. Quickly press the New Ladder Document button on the left to minimize your exposure to this foolishness. The software starts with a blank workspace. The menu and toolbar on the top are the principal means one uses to navigate the TECO SG2 client programming software. Hovering over any button will show a pop-up description of the button in question. The bottom features common ladder logic commands. You'll note most of the buttons are grayed out, indicating they're not active at this time. Click the New button in the upper left-hand corner. The program asks us to select the device of interest from a drop-down menu. For this exercise, we'll be using a TECO SG2 10HRA PLR. Note this window gives a brief synopsis of the TECO SG2 10HRA PLR specifications. Navigate to this entry and press OK. The software takes us to a blank workspace. This is where we'll write our program. Note the workspace is limited to 7 vertical columns. I'll call them A through G, and 300 numbered horizontal rows. Columns A, C, and E on the left are reserved for contact instructions, and column G on the right is reserved for coil output. Columns B, D, and F are reserved for wiring. Note the bottom menu now allows access to a selection of available contacts and coil functions. Additionally, note the left-hand side features a sort of cross-reference field showing the user what elements are being employed in a particular program. This list is especially handy for later referencing or troubleshooting purposes for a larger program. To add a contact or coil to the program, press the button for the contact or coil of interest, and then click the desired destination on the workspace. Here I've added an I input instruction into Rung 1, column A. A pop-up menu allows a user to select basic properties like operand number and make or break behavior. Additionally, tabs allow a user to toggle between alternate functions like timers, counters, and more. We'll examine these additional functions in later lectures. Let's add a make instruction examining input I2. Use the pull-down menu to select operand number 2 and press OK. If you make a mistake, you can always double-click the element to select and edit it, or one can delete it entirely. Note within TECO SG2 client programming software environment, the contacts are designated using ANSI CSA format. However, an actual device will display this program subtly different on the small LCD screen using device format, where a make instruction is designated using capital letters, and a break instruction, in contrast, is designated using lowercase letters. Let's add another make instruction examining input I3 into rung 1, column C. Note the software is smart enough to realize we want them wired together and inserts a wire in column B. Let's put an output Q1 in rung 1, column G. A pop-up menu allows the user to select basic properties like operand number or latching behavior. We'll examine these additional features in later lectures. For now, let's just select the default coil function for output Q1. The programming software places output Q1 in rung 1, column G. However, it doesn't do the wiring for us, since it's expecting another contact in rung 1, column E. Select the horizontal wire drawing tool, A. Don't ask me why they call it A, and insert a horizontal wire in rung 1, column E. If you dork up the wiring, or if the programming software ever assumes an incorrect connection, you can always delete it using the delete button in the bottom row and redraw it as desired. Our program is a series connection of two make instructions examining inputs I2 and I3 and yielding a coil output Q1. One can save this program for later editing and reuse. I'm going to call it demo program. Again, note the cross-reference list on the left-hand side produces a handy-to-use chart cataloging all contacts and coils utilized in this program. Asterisks indicate I2, I3, and Q1 are in use. One can also include comments describing the nature of inputs and outputs using the Note N function on the bottom menu. Note I've included the comments normally close momentary contact red push button for I2, normally open momentary contact green push button for I3, and first pilot lamp for Q1. These comments are extremely helpful features and recommended work practices as our programs grow in size and complexity. The simulator button at the top allows a means of testing and verifying the functionality of a program before going live with real hardware in a production environment. When activated, the simulation workspace shows the status of the program ins and outs as dictated by the simulated input conditions. You'll note several windows open, notably Input Status Tool, Expand Analog, and AT Tool. Move the Input Status Tool into the center of the simulator workspace and push Expand Analog and AT Tool off to the side. We won't be using these tools for this exercise. The simulation utility offered by the TECO SG2 PLR client programming software is admittedly not especially robust. The simulator assumes all field input devices are electromechanically normally open. However, for the purposes of this application, this is most assuredly not the case. Note our comments indicate that the field input device attached to input I2 is intended to be electromechanically normally closed. We can work around this software limitation